All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Tonight, we are going to pick up where we left off last week. Plus, I did a little bit of more work offline. Nothing really worth mentioning too much, but we are actually going to pick up on sort of the next phase of this, which is redoing our asset import pipeline. So we've got some adjustments to make there, and we're going to go over that tonight, see how far we get with it. Before we get too far into it, though, or really at all, I do want to just take a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Lazaron. That is the highest tier of subscription over on Patreon, followed by our partners, Griboli's Inc. and Matt Osgard. That's the next tier of subscription there, followed by the list of supporters that you see here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me to offset the costs rather of running this channel, hosting fees, software licenses, eventually assets, and maybe paying artists, things like that. So all of that goes towards that, and I really appreciate the support. And also, I would be remiss without thanking you guys, the viewers, whether you're joining me on the YouTube side or the Twitch side live, or if you're catching the VOD after the fact. This project and thus this channel would not exist without you guys. So thank you so much for being here and following along. All right. Spiro, you were indeed first, at least over on the YouTube side. Congrats. Thank you for being here. Magetsub and LaFoley, how's it going there over on the Twitch side? I hope you guys are doing all right tonight. All right, so tonight we're going to talk a little bit about asset imports, because I want to kind of change up the way that we're handling this, because it was kind of convenient, but also kind of strange the way that we had it set up. And so I kind of want to rethink how we're handling asset imports in general, and make it a little bit more utilitarian in the sense that we're going to want to use this not only for building the game, but also when we set up an editor, we're going to want to be able to use this sort of same pipeline to go ahead and import assets there. So the thing that we want to keep in mind is, and actually, let me get rid of this console here. So the thing that we want to keep in mind is we want to keep our importers out of the core runtime. So that is because, we may rely on external things for the importers. This is one of the few cases where we actually tend to actually use external, in this case, header-only libraries. Like we're using STB image to load image files. And so we don't want that in our runtime. We want our runtime to only be concerned with the binary format, and currently now it is. And I got thinking about it also, and we also had this kind of weird sort of importer registry that existed that we don't necessarily want to be part of the runtime either. So what we really want is all of our import logic to be separated out into a different library. And it currently kind of is, but I don't think it's in the right place, per se. So where it is right now, we can actually see this with the file path here at the bottom. It is in plugin utils, which is sort of like a debug utility library that we're only going to use in debug builds. But I don't think that this is the right place for this either. I feel like this belongs in our tools, right? Now, whether that is, and I'm actually thinking probably Kohi's tools, right? So we have Kohi tools here. That's the one I'm thinking we should probably put this in. The tools here at the base level is for our game-specific tooling. So, I don't think that it belongs there. I think we need to have something that's a little bit more, at least for generic types of assets. We need to have that in our Kohi submodule, right? So what I'm thinking is all of the known asset types all of the import logic for that is going to exist in Kohi tools. If we have any sort of special types of assets that are game specific, which we may wind up having some of those would actually wind up being under the games tools, right? So we've got two different areas that we can put the tools in, depending on what we're doing, and I think that makes a little bit more sense, right? I don't think that we need to split this out into, like, we do have this Kohi tools version gen. I don't think we need to split out the importers into a separate library from that. I think just including that under tools should be fine. We have this tools main here. We could always include some command line options for that. We have that. One thing that we need to bear in mind is we need a couple of methods of importing assets, right? One thing that I talked about sort of from the very beginning was, or at least one thing I was thinking about was, we have some sort of program that reads the asset manifest and performs auto imports on everything within that manifest. That could be one method of operation, right? But we also need the ability to import individual assets, right? One at a time. And because that's typically going to be the way that it works with an editor, we need to be able to do that as well. I'm thinking that we could probably take the design of having our importers, so to speak, be just publicly exposed functions that we can call, and we basically just use command line options to wrap around which importer gets used and how it gets called and so forth. And I think through that we should be able to set up something that reasonably works. What I do want to do, though, is keep things so that they can not only be used at the command line, but also referenced in code. So, they're usable sort of from both perspectives. Because, again, if we have a central importer tool that we have in Kohi, right? Kohi.tools, rather. That's only going to know about the all of the importers for the known types of assets, right? It's not going to be able to take into account any types that we add here at the game level. So we're going to have to do a little bit of thinking about that, but I think the first step of this is to get our importer logic first off out of this library, so out of the plugin utils library, and moved over to Kohi tools, right? So we're just going to basically lift the importers out of there and move them over. And then we're going to, obviously fix all the errors in here. We're going to do away with things like the import options, and we're just going to expose options in the function calls themselves. We're going to do away with the interfaces that we had as well, and we're just going to kind of keep things as simple as possible, and hopefully that all works out. So that is what I'm thinking currently. Let me catch up on chat here. Spiro, you were first over on Twitch and you have proof. Nice. Pound in bed, all the things, 12 gigabyte binary. Gigabyte, sorry. Yeah, if only, right? I'm eventually going to wind up doing that with shaders, actually, probably. Because I think the shaders, the byte code that we generate like that is going to wind up working that way. Maybe. Depending, I have some thoughts on that. Okay. So, what I'm thinking is, under tools, right now we only have source and vendor, right? Which I think this already actually has STB image in it, which is perfect. Stuff like this KAsset importer image, we're just going to move. I think we'll probably move the file first, and then we'll go ahead and refactor it. Sherry Makes Art is raiding with a party of 40. Thank you so much for the raid. What did you get up to on stream? Welcome, raiders. We are actually just getting started here. on stream. I don't believe I am familiar with you. What do you do on stream? Just a quick shout out there. And I am going to go ahead and toss you a follow as well. There we go. All right. All right. So, mostly code. Today I was working on an old Advent of code problem from 2022. Nice. Okay. Awesome. Well, I gave you a follow. So, and thank you for the follow. And I will definitely check you out next time I see you online. Thank you so much for the raid. Like I said, I will go ahead and give the quick and dirty introduction as to what we are doing here. So we're currently in a bit of a refactor phase, but I'll kind of start from the top. So for those of you who have not been here before, we are building a game engine from scratch using C and Vulkan. And Vulkan is our primary, or at least our initial rendering backend. And I say that because we also are going to support Direct 3D and Metal at a minimum in the future. And so this was designed to be an educational series on a way to build a game engine. It's not necessarily the only way, or not even necessarily always the right way. It's educational and exploratory, right? So we try all kinds of different things. This is a highly experimental channel. We're constantly trying different things. Some things work, some things don't. We do a deep dive into those things either way and investigate why they didn't work. And that's actually kind of one of the things that we're doing now. So it started off as sort of a tutorial series. We quickly outgrew that format, and we ultimately landed on the live stream format that you see here today. And so we've been progressively building a game engine from scratch, which is currently broken. Unfortunately, I can't demo it, but I do have some screenshots that I can at least show you, although they're a little bit dated. Regardless, the screen that you're looking at here is actually the project website, which I'll link there in chat. And from there, you can access the YouTube channel, Twitch, and then we have a Discord server with about 1,000 people on it, and a GitHub. So the engine itself is open source and free. So it is Apache 2.0 licensed, which basically means that you can use it for whatever you want, whether it's personal or commercial, it does not matter. There will never be any sort of licensing fees or royalties of any kind ever. It will always be free and open source. The only thing that I ask is that if you use it, you say you used it. Now, that being said, this is a very early engine. It's still in heavy development, so I don't suggest using it now. We have just started kicking off the first game project on this, building an actual game from the engine, or in the engine rather, that we have built from scratch. But I digress. So if we scroll down here a little bit, we've got a whole bunch of information about the project itself. Here's a couple screenshots. Again, these are somewhat dated. We have a physically based rendering model with cascading shadow maps. We've got the startings of sort of an editor where you can kind of click objects and manipulate them, move them around in the scene, transform them and whatnot. And like I said, everything here, with the exception of a couple of imports libraries, is built from scratch. So we do have bitmap fonts, we have UTF-8 fonts working, we've got a lot of different things in place. So we're basically building the systems that we need as we need them. Every time that we need a new system, we'll go ahead and just add it in. And so this is kind of where the project is at the moment. I also did forget to mention this is cross-platform, so it does run on Windows, Linux, and Mac OS desktop environments. We do have other platforms planned for the near future, that being eventually mobile. I'd like to get this ported to the Steam Deck, Nintendo Switch eventually, maybe Xbox. We'll see. But for right now, we're just supporting the desktop environments. So, that is pretty much the quick and dirty of it. We are making as far as the game itself, it's very, very early days in that too. Let me pull up, give me 1 second here. So we are making a isometric 3D isometric rather action RPG called Shadows of Illumina. So that is all the references to Illumina. That is the game code. And so it's designed to be somewhat open world, meaning you can explore different places. It's not super linear. We'll have a storyline which is also somewhat non-linear in terms of making choices, and that affecting the outcome of the story. We've done a little bit of world building. This is not really a game design document. It's kind of just a bunch of design that we've come up with on stream, having to do with a bunch of sort of the background lore, and whatnot. So we've got about I think 29 pages in here. We're going to eventually expand this out a lot. We've got mechanics. We've got there's a little bit more war or lore with wars in it and stuff like that. We've got mechanics here, AI, inventory, abilities, skills, crafting, weapon enhancements, mounts, that kind of stuff. Resources, attributes. We've got all the different item types in here, armor types, all this common RPG stuff that you would need. The difference between this and most RPGs is this is going to be not based on levels and experience. We are not going to have those things at all, unless I change my mind about that, which I don't think I'm going to. So the way that you progress is purely by upping your attributes via items that you find in the world or completing quests, and your gear, basically. And that's about it. So, yeah, that is what we have at the moment. I could also pull up, even though it's woefully incomplete as well, we actually have done a little bit of world building in terms of a map. Just give me a second here to pull that up. Takes a second to load. And this is something that also is a little bit under construction, but like this is what the world is going to look like, right? So we've got all of these different. We've got 3 different continents. These 2 continents are mostly done. This one still needs a lot of work. But we've got our zones kind of filled out, and we've done a little bit of lore having to do with how all this goes. So we've got previous streams that go over all that stuff. So I'm not going to go into it in detail, and we'll get to it in future streams anyways. But I just kind of wanted to bring that up as well. All right, let me catch up on chat on both sides. So I'll go ahead and tackle Twitch first, and then YouTube. I see you guys have got comments over there. I'll catch up in just a second. Okay. Sick NeoVim setup, by the way. Thank you. I actually do have a command. LaFoley was trying to execute it. It's NeoVim. I should make it NVim, but it's my NeoVim setup is there. So I actually wrote up a article on what setup I'm using, all the plugins, all that stuff, and that's also got a link to a GitHub with the config, which is probably about 98% up to date. There might be some things that are off in that because I haven't updated it in a few months, but yeah. Crazy way above my head. I mean, we all have different things we're good at, right? No big deal. This is an educational stream, right? So hopefully, you can get something out of it. This is serious code. Yeah, I mean, it's seriously broken code at the moment, but yeah, this is all written from in C. Yep. And cross-platform. Holy crap! Yeah, that was one of the early goals of the project, was to get it cross-platform as soon as possible. And so I'm actually on Linux at the moment, and Linux is a first-class citizen as far as this is concerned. So that's the platform that I develop on primarily, with Windows as a secondary, and then Mac OS as a tertiary, because we don't have a metal layer for it yet. So we rely on Molten VK to sort of make that translation for us. But how long did it take to get to this point? So let's see. It is about 4.25 years, but large asterisk here. That is with me working on this less than part-time hours, right? So, if I were working on this full-time, we've probably got about a year's worth of work here. But I do have a full-time job, so I do this as my hobby. I obviously wish I could do this full time, right? But that's just not in the cards. So I do work on this, maybe 10, 15 hours a week tops. And so, I do work a little bit on this off stream, but most of what we do is on stream. So, it's 4.5 or 4.25 calendar years, but it's not that much actual development time across the board. Most importantly, it has dingosaurs. Yes, to go with our dingus-oriented programming. Is there a reason for the custom game engine, like full control over mechanics, or is an issue with existing game engines? That's a good question. So thank you guys for the follows, by the way. So the reason we have a custom game engine, well, it's several fold on this channel, right? So building game engines from scratch is not something that is put out there a lot, right? There's not a lot of open resources that go into depth and things, right? There's a lot of high level stuff, but there's not really anything that goes through the actual process of like, hey, we're creating this like file new project, creating it completely from scratch, right? And we've done that here. And so this goes through the process of creating an engine to walk through all of the various things that go into making a game engine, in the hopes of wanting to get more people interested in game engine development. Why do I want more game engine developers? Competition, right? So the big guys, the Unreal, the Unity, and now Godot or Godot, however you pronounce it. Those are sort of the big three, right? But I believe that competition drives ingenuity, right? Drives us forward, right? And the more competition we have out there, the better. So my goal with this is to hopefully get people into game engine development, to go out there and make awesome stuff, and learn how to do it along with me, as we go through this, and hopefully that motivates people to go out there and make awesome stuff that we can all benefit from. So that is the overarching reason on this channel. But also, I've always built game engines for the games that I've released in the past, whether it be professionally or on contract work or whatever. And most of the time, it's because those sort of one-size-fits-all engines are entirely too large and complicated for most projects' needs, right? Most games out there, aside from AAA games, do not need all that complexity. And so, that is one of the reasons I prefer to roll my own tech, as well as obviously the benefits that go with, having the control over that stuff. So, let's see. Have to run and eat, but I'll definitely be checking this out more. I appreciate it. And thank you again for the raid. I really, really appreciate that. Reminds me of Gillinor from RuneScape. Fair enough. Been using Helix and I love it. Yeah, Dr. Elliott, I know you've been trying that. I've not actually used it, but the way that it selects text versus the operation, that's reversed from what Vim does, and I don't think I could wrap my head around that. The resource I've been looking for. I hope it helps. Yeah. Okay. 10 million subs and he'll rewrite Kohi and assembler. That's not a threat, that's a promise. 10 million. You know what? Baguettes. I see what you've done there, right? I've already made a deal for 1 million subs, right? So if we hit 1 million subs on my YouTube channel specifically, the goal is if I hit 1 million subs on there, that I will drop what I'm doing temporarily and write a Vulkan render in assembly. Yeah, so that's the goal there. So that's probably where this is coming from. You're talking about writing an entire game engine in assembler. I suppose if I hit 10 million, sure, we'll do that. Why not? Why not? We'll go ahead and make that deal. I'll take that. Because if I hit 10 million subs, that will be the least of my issues. I don't think that'll ever happen, though. Good answer. Thanks. I appreciate that. All right, cool. I've heard game engine work can help someone get general game dev jobs, but honestly seems interesting to learn how things work in general as well. Love these streams. Yeah, so that's kind of the other thing that I left out is doing this stuff and learning about this stuff helps you understand what is going on underneath the hood of these larger game engines, right? So that when you're doing all this stuff, whether it has to be, loading assets or interfacing with the GPU, you actually understand what's going on under the hood, and that just makes you much better at dealing with that high level code. My YouTube channel is I think it's in the description, or not description, the about, but it's just youtube.com/Travis Vroman. So it's the same channel name. It's just that over on YouTube. Let's see. Challenge accepted. Yeah, exactly. What's a Vulkan renderer? So Vulkan is a graphics API that is used to interface with your graphics card, right? So it's an interface that's used to send commands over to that and execute it. You may have heard of OpenGL in the past, or perhaps DirectX/Direct3D or Metal. Those are other examples of graphics APIs. So a Vulkan renderer is a renderer that is written around the Vulkan API. You can cheat and use Fast Assembler to make assembly code more convenient with all Phasm's macro glory. Magats, I may have to ping you on that because I don't know anything about it. Don't know what you're doing, but how long can it take to learn Vulkan? I'm thinking to start with OpenGL, then Vulkan. How long will it take? 4 months or more? That depends on your skill and what you know about graphics programming. So you're absolutely doing the right thing with starting with OpenGL because it is an easier barrier to entry. Vulkan is much, much, much more complicated. Depending on how much time you can spend on it, depending on how much, how quickly you learn, that can vary that. Let's see. Technically, NVIDIA writes the driver. It's a driver interface. So it's not... you can think of it as a driver interface. I mean, yeah, the driver is kind of the implementation of that interface, if you will. So yeah, you're not wrong. And so we code against that interface. All right. What IDE is that? This is NeoVim. So it's not really an IDE, it's just NeoVim. All right, let me catch up on the YouTube side. Looks like we have a bunch of comments over here that I was missing because I was reading those. So let's catch up on that real quick. Singy, hello, how's it going? Good to see you again. Let's see. Seems Kohi is missing a feature. Toggle between full screen and windowed. And in windowed mode, how to hide, not minimize the taskbar, the console window. So actually, these days, all full screen mode is. Most graphics applications don't actually go into true full screen mode, kind of like the old school way of doing things. What you get nowadays is typically a maximized window that covers the whole screen and just has no border on it, essentially. And so we could add that, but I probably won't do that. I probably won't bother with that until we get closer to release if I need it. But yeah, it'd be a small thing to add. It's on the list of things to do. Let's see. Let's see. How old is Kohi? So yeah, it's 4.25 years old. Yeah, I started it in 2021, early 2021. What are the projects you'd recommend and language to focus on for web dev getting into game development? So I would probably start with, okay, so that's a bit of a loaded question, right? Do you want to make browser games or do you want to make locally running games like what we have here that run on the desktop, right? So if you want to learn like what we're doing here, I would say learn C and then C++. Not in the opposite order, because C will teach you what C++ is trying to hide from you. If you're looking to do web-based stuff, obviously JavaScript and WebGL are probably the place to start. I used to suggest TypeScript. I don't really suggest it anymore because JavaScript's come a long way. Um, let's see. I'm kind of glancing over the functions here because you guys are just kind of talking to each other, so I'm going to skip that. Just locally running games. Okay, so if you're wanting to do just locally running, then absolutely, I would say start with C first, get good with C, and then move to C++. And I know that seems a bit counterintuitive, right? But here's why. So C you can think C++ you can think of as a superset to C, right? It's kind of built on top of C. It's a lot more than that, obviously, but everything that C++ does is built on top of what C does, right? So anything that C can do, C++ can do within reason. There are a couple exceptions to that. So what I would suggest is you start with C. That way you learn about things like pointers and dereferencing and the way memory works and all that stuff before you move on to C++, because C++ actually tries to throw all these complicated topics at you and tries to hide, the way that pointers and stuff work. And they also, try to introduce something called smart pointers. And while those have their use, if you don't understand how a pointer is working under the hood, it's going to make it a lot harder for you. So I say start with C, then move to C++. As far as getting good with C, the thing that I always suggest for anybody that is looking to learn C is to write your own string processing library from scratch, not using any of the standard library stuff. And by the time you do that, you will have a pretty decent command of the language. Now, what do I mean by string processing library? If you look up any higher level language and their string processing library, say C# or Java or JavaScript, look up all the list of functions of all the things that you can do with a string, re-implement all that stuff in C from scratch. By the time you're done with that, you'll be more than comfortable with C. So that's the first thing I say to start with. And then the second thing, once you get into graphics programming, start with OpenGL. Don't start with Vulkan, because Vulkan introduces a lot of concepts that, frankly, would be a lot easier to understand if you understand GL first. So OpenGL is kind of a more higher level API. It kind of hides a lot of stuff for you, deals with a lot of state, handles state for you, handles synchronization, things like that. Stuff you don't want to have to worry about while you're still trying to learn the concepts of graphics programming. So, once you get a decent, grasp on the programming language that you're going to use, whether it's C or C++, I would say try it in C first. Then go ahead and start writing a renderer in OpenGL. And by the time you get there, you'll probably know how to proceed once you get to that point. I hope that makes sense. All right. All right. Thank you guys for the follows, by the way. Appreciate that. Let's see. Let me just catch up on how did you learn to code? So, using things that nobody has heard of these days, I guess, unless you're as old as I am. So I actually started programming when I was about 7 years old on an MS-DOS 5 machine that had something called QBasic installed, Microsoft QBasic. And that was a antiquated programming language that Microsoft came out with that you could write. And that was the first thing that I started actually writing, because it actually came with a locally installed manual on how to actually use everything. The help files for it were really awesome. And so I started to learn using that. And then just over the years, just graduated to trying different things. I actually jumped from that. I did a little bit of web development stuff, and then I jumped over to C# when that first came out in 2001, somewhere around there. And I learned that from reading the Microsoft language specification on it, and then built a whole bunch of stuff with that. And then I went to C++, and then I went to C. And so I did it completely ass backwards, which is it made it really hard on me, which is why I'm saying if I were to do it again, I would do the opposite order in terms of languages. So I would say C, C++, then C sharp, right? But yeah, that's more or less kind of how I learned, I guess. The quick and dirty answer, anyways. It's a bit more involved than that, but yeah. It'll confuse the crap out of you when you finally go to learn C++, though. Yeah, yeah. I mean, I guess that's true, right? Like C++ is very, very complex. There's reasons I don't use it, right? And that's one of them. At what point would you recommend moving from C to C++? So, I would say when you're at the point where you can write code that, obviously the string library thing is a huge thing. When you can comfortably write code for handling input, whether it's file input or user input of any kind, when you can write code that handles. Let me think. So files, writing graphics to the screen, not just text, but actual graphics. However you decide to do that, whether you use the Windows API or whether you use OpenGL or something like that. When you can also figure out how to competently, make audio play through the speakers, which is actually, when you're not using a library, more complicated than you might think. When you can do those things using, basic like OpenGL, OpenAL, stuff like that, and you can comfortably, implement, say, any, or not necessarily any, but a lot of algorithms out there or data structures out there in C, without having to look up how to write syntax and stuff like that. When you're at that point, you could probably switch over to C++, but I wouldn't do it before then. Can you tell me how long it will take to be able to deal with a Vulkan and have the ability to land a job? I want that to be my career. I wish it won't take me years. Well, I have bad news for you. It is going to take you years. So, even if you do it every day, it's going to take you years. And that's okay, because junior roles exist for a reason, right? And do remember also that you can always get your foot in the door at some company doing something slightly unrelated and then transfer to that position when something opens up and your skills are bumped up, right? So, something like Vulkan is one of the most complex APIs you can actually work with out there. And I won't go into all the reasons why, other than you're dealing with all the most complicated parts of programming, including asynchronous programming, which if you've ever dealt with that on any level, you'll know what I'm talking about. But just wrapping your head around Vulkan and all the concepts with it alone will take you a long time. Usually what I tell people when they're learning Vulkan is to read the Vulkan spec, which, let me pull it up. So this is the Vulkan spec, right? And you can just Google for it, right? This page is actively loading. This is how long the spec is. The page is loading in Chrome. Still. And it's nothing but HTML. Right? So you can see how fast I'm scrolling. And look at how the scroll bar is moving, right? It is long. In fact, Chrome doesn't even like I just resized it in Chrome, about freaked out, right? So, what I tell people in terms of learning Vulkan, right? And this is not to scare people off, but it's to let you know what you're in for. Vulkan, this is the table of contents, which also takes forever to load, right? You need to read most of this document several times to understand what's going on here. In addition to looking at code samples and whatnot. The thing I usually tell people when they're learning Vulkan, because I've done this myself, is for an intro to it, a tutorial's fine, but you need to read the spec. So I tell people, read the Vulkan spec, write a simple renderer. Get it working? Great. Throw it out. Delete the code. Completely wipe it clean. Read the spec again, because I guarantee you didn't understand every bit of it. Write another renderer. Get it working. Add some stuff you didn't do last time. All right, you're at that point. Wipe it out. Delete it. Get it off your computer again. Read the spec again. Write it again. Wipe it out. Do that like 6 times. And I guarantee you, every time you do it, you will pick up new stuff and you'll get better and better at it, and you'll get faster at it. But yeah, there is no way around it. There is only a way through it, right? So, stuff's difficult, but not impossible, right? Terrifying, yes. But if you do it that way, once you finally do get it, you will be unstoppable. Following along that one Vulkan tutorial website, and after 700 lines of code, I'm finally close to having a triangle. Yep. I mean, it took us 21 episodes, I think, in this series to actually get a triangle on the screen. That's mostly because we were also building up other subsystems for the game engine, but yeah, still. Actually, no, that was just clearing the screen. Yeah, I think the 21st episode was just clearing the screen to a color, right? Which is sort of the starting point of any initialization of a rendering API. Let's see. Starting from ground zero, it'll take 10 years from no code to Vulkan Master. That's probably about right. Again, it depends on your learning speed and how much time you can devote, right? But, the key is to be writing code. You can sit there and you can read all day long. You can read tutorials and theory and all this other stuff, right? And that's all well and good and important, right? But what's actually going to help you is sitting down, getting your hands dirty, and just writing the code and just banging out code over and over and over and over again. They say it takes 10,000 hours to get good at anything, and that's absolutely true. I would say graphics programming is probably a little bit more than that, but does Vulkan API still not come with some utility library to pick a device and configure a swap chain? Those are the most stupid busy work with Vulkan. Actually, those aren't even that big of a deal. That's not that much code. It's far more code to actually set up a pipeline, graphics pipeline, and get shaders working. Also, banging your head on the desk often. Get a small pad for your forehead. Yes, that's true. My forehead is flat. From, it's fine. But yeah, I mean, it's fairly simple to do that. So, I don't consider that a lot of code anymore. In fact, if we look at our Vulkan backend in here, which contains most of our Vulkan logic, not quite all of. There's maybe another 1,000 lines outside this. This is a 5,000 line file. And this includes a custom Vulkan memory allocator, right? You can tell an experienced graphics programmer from a new one because our heads are flat from banging against brick walls. Absolutely, yeah. My forehead here is flat for sure. Let's see. So, okay. I think I might have finally caught up on comments. I think. All right. Which, speaking of which, looks like we've got some errors in here that we're going to have to fix for our asset stuff. I wonder if we should do that before we do the importer stuff. I think I might move the importer code and then fix it later. We'll see. So, what we are talking about here is essentially taking all of our stuff out of plugin utils. And we don't have any exporters yet. We eventually will have that. But our importers are actually what we want to move, right? So, do we actually have... Is this... Yeah, this doesn't even have an implementation anywhere. Okay, I'm going to get rid of that one. All right, so currently we have importers for the following asset types. So we have images, right, which is like your JPEG, your PNG, that kind of stuff. And then we have bitmap fonts. So that is loading essentially a configuration file full of glyphs and kernings and stuff like that for a bitmap font. And then we also have audio, so that's importing, like your MP3 or your OGG formats. And then we have static mesh OBJ specifically. So we have an OBJ importer, which also is what handles the MTL file imports, which is the OBJ or the wavefront material definition file. So that kind of handles that. We probably ought to split those out at some point, but these are the importers that we need to move. So I think for now, actually, you know what? Let me do this. Let me take importers. I'm going to take the entire folder for now, and we're going to put it into Kohi Tools source. I think we're going to actually put it right there, right? So we've got all those importers there, and then I'm going to remove that, right? And so now we can actually have these in the correct spot. So we'll go ahead and open up this, and I'm going to have to actually clean the build and rebuild it because we've moved stuff around, so there's going to be object files that don't make any sense. Okay, and it's still bleating here. So this is the importer for the images, and so we need to actually switch this up from our sort of generic interface function call here to something that is a little bit less generic, right? Because we're moving away from over genericizing things, and I realize that's not a word, but it is now. Dang it. So what we're going to do is essentially the way that this works is we do have a data size and a data array of bits, right? And then we have, or bytes rather, and then we have this void pointer params, right? And so I actually want to change this params. I want to get rid of this, right? Because the only thing that we really have here is this old import options structure, which I want to get away from, and we actually want to use instead. We just want a B8 flip Y and a K pixel format. Right? We also don't have this sort of old school image format stuff anymore. Because we used to have a separate set of formats between this and texture formats. We've unified that to be pixel format. So now when we go to actually do this, let's see. We should probably, thinking about this, we can take a pointer to a K-asset image, right? Which we don't need this anymore for that. And we could basically write out to it as we always have, or we could simply just return a pointer to that. However, if we return a pointer to that, then we have to allocate new memory, so I think I'm probably going to keep it like this. So if we take this and go to, let's see, do we actually have, here we go. So I'm just going to replace the definition there. So let's just fix the code issues here. And we don't need either of those things anymore, right? So nice and clean. So when we go to import an image, essentially what we're going to do is we're going to have this interface point, right? Which actually we don't actually even need this. We can actually remove that completely. So we just have the size of the data itself, right? So this will have already been read in from a file, right? So we'll already have that data. And then whether or not we want to flip on the y-axis, what the output format should be, and then the asset itself. So the other thing that I want to do is I want to provide a second interface point. And we'll do, let's see, actually, let's rename this, right? So this should be KAsset image import, right? And then KAsset image import from path, right? And this one is just going to take a constant character array path. And then it's going to take, these same properties here. There we go. And so what this one will allow us to do is, if we're calling this from like a command line, we can just pass it in a path. And then we can use this to sort of open up a file, read out the data and the data size, and then call this internally anyway. So they'll all go through the same code path, but we won't have to, necessarily handle all of the file reading from the place that's calling this. So if I take, let me rename this. So I think we're just going to say KAsset image import, right? Isn't that what I said that should be? KAsset image import. Oh, right. The importer does not need to be there anymore. Okay. So there used to be this sort of concept of an importer, which was a structure that would hold any sort of static type of data that we need. We don't need that here, so we are going to get rid of it. The other thing is anything like this where I had sort of hard-coded a function name in here, we are going to change that to use just a, a string that we're going to pass in here, which is going to be function, which will give us the function name automatically, right? So that way we don't have out-of-date stuff going on there. So this is going to say it basically requires data size and data. Requires a valid pointer to data as well as a non-zero data size. All right. So if we don't have those two things, we immediately boot out. We don't do anything. Defaults, we no longer actually need this. And then we actually don't need this options thing. We don't need any of this either. The next thing that we're going to do is our typed asset, which actually we don't need either. All right, so the way that this works is we have a required channel count, which we figure out based off the format that gets passed in here. We actually do need to do some work here because we only supported RGBA 8 here. And so we actually do need, to figure out the required channel count and the bits per channel for this in here. We were always saying that we are going to do this in the future, and now is, I guess, the best time to do it. Let's see. Every platform has their own API. Vulkan will cover Windows, Linux, Android. Partially, it can cover Nintendo Switch and PlayStation, but Xbox needs DirectX, and if you want to ship it on web, then you still need OpenGL ES. Any advice on how to cope with that? Yes, that's a great question. So we actually thought about that in the design of the engine. So what we have is, just to kind of give you an idea of the project structure here, we have Illumina, which I said was the game that we're creating, right? So that this top tier of folders all has to do with the game itself, right? And so we have the app, which is the executable that we build. It's the end executable that we build that consumes the engine. And then the lib is a hot reloadable game code library, right? And we'll come back to that. Submodules under here are basically dependencies of this, right? So we have something called kbuild. I'm not going to go into that now, but it's essentially going to be our new build system going forward when I finish it. But that's an offline project that we'll talk about in the future. So Kohi here is the actual engine, right? And in the engine itself, let me expand this a little bit. We have a series of libraries, right? So we have Kohi core, which is what contains our things about assets, some of our containers, right? Like our array, our dynamic array, free list, some of our data structures, some debug stuff like asserts, various identifiers, handles, UUIDs. Our math library lives here. Our memory and our allocators, our memory management and allocators all live here. Various parsers exist. So case and parser is like a storage format language that we wrote on stream. Our platform layer is here, right? So we have Windows, Linux, and Mac OS in here for now. And then, things like serializers, our string library, threading stuff, time, various utils, all that kind of stuff, right? So that's core. And then we have let me collapse some of these. Then we have runtime, right? Which runtime is sort of the core that the application actually makes use of. So it's where our game loop, our main application loop exists. It's where all of our systems exist, and so forth, right? So our core is designed to be used by the runtime, but it's also designed to be used by our utilities, right? So that's the reason for the split there. Runtime is used by the application, so obviously we have our application interface here, but this is also where a lot of our systems exist. So our asset system, our camera system, font system, job system, all these various systems, right? And then the biggest thing out of this, to answer to your question, bring this back around, is this is where our renderer in part exists. So what we actually have here is what I call our renderer front end, right? And so you'll see here that we have renderer front end. So our renderer is split into two halves. We have a renderer front end and a renderer back end. The front end is what the rest of the engine interfaces with. It's a graphics API agnostic system that the rest of the engine communicates with, right? So as far as the rest of the engine is concerned, it doesn't know whether we're using Vulkan or DirectX or OpenGL, or it doesn't care, right? All of that stuff is abstracted elsewhere. That stuff all lives in the renderer backend, right? So the front end is sort of our generic interface for the rest of the engine. And the renderer backend is like where our Vulkan exists. And we pulled up the Vulkan backend file a little bit ago. So the way that the Vulkan backend works, or the renderer backend rather, is rather than being just a standard part of the runtime, it is actually implemented as a plugin. So we do have a plugin system in place. And we have a Vulkan renderer plugin. So we see here that we have Kohi plugin renderer Vulkan, right? So this is a renderer plugin, right? And so what that essentially means is that we can use different renderer backends depending on what the application specifies it should use. So the application can say, hey, I want to use Vulkan, or I want to use Metal, or I want to use even a headless renderer, right? Which would be used for, integration testing or something like that, or unit testing or what have you. Or if you wanted to run the application but in headless mode, where you didn't need rendering to happen, but maybe you needed physics, physics to be calculated or something like that. You're running the full engine without actually having the graphics front end. So you could actually use that as a server. So you can then take this code and use that as a server, and then use another version of it as sort of the client and connect them that way. And so this is how we've solved that problem, right? So our renderer APIs, our graphics APIs, are all in renderer plugins. So we have one for Vulkan. We have not written any others at the moment. But when we go ahead and do DirectX, there will be a DirectX one, or more aptly Direct3D. There will be a Metal one when we get ready to write that one, which we are going to do. We might have an OpenGL one as well. We'll have to see, depending on what we plan to support, and any other platforms that or render APIs. Our audio system works the same way, right? So you see we have an audio plugin here that's using OpenAL as its backend. So I hope that answers your question. That's how we get around that. So currently, Apple is using something called Molten VK, which is an implementation of Vulkan on Mac OS that essentially makes a translation to Metal. And that's how we're getting around that for now. But eventually we are going to write a proper Metal layer for it. So what to learn: Vulkan, Metal, OpenGL, and DirectX. You need to know them all, basically. Depends on what you want to develop, right? So you don't necessarily need to know them all, right? Like a lot of AAA studios, they'll only use DirectX because they only target Windows, right? So if you're going to go into AAA, more than likely, knowing DirectX is enough, or Vulkan, right? Think OpenGL is still the most flexible API, especially with the Zinc driver. Yeah, I mean, OpenGL is great for learning, but like, there's lots of things that you can't do with it now, right? You're scared that Apple will drop OpenGL support one day. Well, they already don't support beyond 4.1, right? So if you want to use 4.6, you're out of luck, for example. Lipoli, your solution is that you just don't support Macs. So I wanted to make something that supported all of this out of the box, right? Because as far as I'm aware, and I think this is still true, I don't think anybody supports all three desktop platforms for a series like this online. I think this is the only one that does. I could be wrong about that, but... Hello, new here, front page recommendation. Are you serious? Drek, I was on the front page? That's crazy. Well, welcome. First time chatter, welcome, by the way. I'm catching up on comments, so I appreciate you being here, and welcome. Feel free to ask any questions if you have them. With Zinc, you'll get 4.6. Okay, so I haven't looked into that, but I don't plan on doing OpenGL for Mac OS. So, nice, really good design, but doesn't so much indirection cause performance hit? Not really, because... no matter what you do, you're going to have layers of indirection anyways. So for GL or Vulkan, for example, you've got to load function pointers anyways, right? So we do have an additional level that goes through where there are additional functions that are being called, but like trust me, that's not going to be where our performance hit is. Not by a long stretch. And if it winds up being like if let me put it this way, if we wind up hitting a performance bottleneck because of indirection for our renderer, then we've got some damn optimized code, right? I don't think we're going to be at that point for quite a while. Well, especially while we're still building it, Have you written game engines with C++? Is it worse than C? So yeah, I've written some stuff in C++, but I've never used anything newer than C++ 11 for game development, just because of compilation target support. But also, the last time I used C++ for a game engine was several years ago, so... I hope that makes sense. I just gotta hydrate real quick. So I actually wound up on the front page. That's nuts. That's the first time I've heard of that. Front page of Twitch. Interesting. Okay. All right, so let's jump back to this. So we need to do some... I thought you had to apply for the front page. I don't even know. If that's an option somewhere, I have no idea. So, yeah. I don't know. All right, so the other thing is we no longer have image KAsset image formats, right? We've standardized that all into pixel formats. So we have in fact, I think I'm actually just going to go here and do this. In fact, let me grab this. So these are all the pixel formats that we have currently. So what I will do is we'll just sort of shift these around. So let's see, how do we... I guess we could probably group them by bits. Actually, there's not really a way that makes sense to group them. We should probably all just... okay. I guess just a stupid switch is probably the way to go. So let's get rid of this. So first and foremost, this unknown is going to come down with our default. So that's an unknown. That's sort of like an invalid format, right? So if we pass that, we're doing something stupid. And we will default to pixel format of RGB8, right? That's going to be our default case, and probably what we're going to use 90% of the time. I don't really see a better way to do this, though, unfortunately, than the stupid way. So we're going to do the stupid way, which is basically this. And then I'm actually just going to copy pasta this a couple times, and what we're going to do is just decrement the channel counts, right? It's going to be the easiest way to do it, rather than switching through it twice, I think. I mean, I suppose we could have some sort of lookup table, but that's a little bit more complicated, right? This is going to be quick. So sometimes having a little bit neater code isn't necessarily going to be the fastest solution, right? Whereas this case definitely will be. Essentially what we need, you know what, in fact, I can actually take and copy. I can actually copy this. And then just change all of these things to 16 all the way down. Right? And then bits per channel is going to be 16. Right? And then grab these again and do the 32s. Did I hit the wrong button? Yeah, I did. There we go. So this is going to be, I guess I'll do this. Okay. All right, so that should cover us for that. And then obviously as we add more formats, we'll need to come in here and add them. But these are purely for sort of the output format. In fact, maybe we should probably rename this to output format, right? Just to sort of make that a little bit more explicit. In fact, I'm going to do that rename here as well. Outputs, formats. And we'll do the same there. Did I also, I don't know if I copied this over. No. So I need to define this guy as well. We'll come back to him. All right. So we've got that converted. Let's spit out the function name here as well, just so we know exactly where that's coming from. All right, so this is the call to STBI. So this is, you know, one of the places where we're sort of allowing ourselves to use libraries is on our importers, right? Because I'm not going to write, you know, all of the parsing for all the various image formats. It just doesn't make sense. The STB library handles this more than fine. So this is one exception I'm willing to make. So all we need to do here is just indicate whether or not we need to flip the image vertically. And then let's see. We have a note here that we are loading the image, but we are forcing 4 channels here for now. So why is... So required... Okay, so this is not necessarily correct. So this note is going to go bye-bye, because that's rubbish. So channel count rubbish is not going to be rubbish anymore. We're actually going to use that. So let's actually just call that channel count, right? And we're going to use, let's see. Typed asset width height. Okay. So we don't need typed asset. We need out asset. Okay. And actually, instead of this should be out asset channel count, right? And then we don't need... Oh wait, what is channel count? Is that that's a U8? Okay. So this expects an I32. I mean, I guess we could just cast it. Yeah, we'll just cast it like we did the others. I'm normally not a huge fan of doing that, but we know in this case that's going to be safe. So we'll delete this, check to see if we got pixels. Image importer failed to import image. And then, so we do not have a path here. Now we could pass a name here, right? But then that requires us to pass a name for this, which we don't necessarily always want to do. So I think what I'm going to do is, for this one, we're just going to output just the error message and not worry about the rest of it. There we go. So we'll do that. And then we'll do, let's see, actual size, bits per channel divided by 8. Yes, okay. Times channel count, so that's going to be, oh, you know what? That's going to be out asset channel count times width times height, right? So that's going to be the actual size. The pixel array size is going to be actual size. And then actually, why do we have... Are we actually using actual size anywhere other than... Nope, we're not. Okay, let's just do this. Get rid of that. All right. Querying is down below. Okay, I don't think we need this, but I'm going to keep it as reference in case I need it for some reason. Actually, though, this is the same as this up here. No, we can get rid of that. That's actually defunct. Okay. So we need to calculate MIP levels. So that should just work. In fact, don't we actually have... I thought we actually had... I thought we had like a graphics utils, or is it asset utils? I could have swore that we had. I could have swore that I actually... Yeah, calculate MIP levels from dimension. Where's that? Render type utils. I was going to say, I thought we wrote a function that did this. And we did. So all we really need from this what does this actually require? Width and height. Right, so we can take all of this and just do that. Much simpler. We don't need this anymore. All right, let's see. Serialize and write to the VFS. Okay, so this is something that I think we should probably not do. So this step here is actually writing out an asset. Now, I guess there's two schools of thought with this, right? So the way that this works currently is we take in our data, right, and our parameters, and we essentially decode that file, that image file, write it to disk, and then also store its properties in this pointer to an asset image. And I'm wondering if we should maybe separate that out, right? So like maybe the write portion of that should be like a separate step, where maybe we can say, let's see. So when we go to write this, in fact, it actually might not be able to do so without the name. So we might actually have to split it out, whether we want to or not. VFS asset write needs an update because it takes a generic K asset, which is not going to be what we want. Because that contains package name and all that good other stuff, which we don't have anymore. So we're going to have to give our VFS a little bit of a visit. All right, let me see. Thanks for the intro. Yeah, no problem. I hope that helped. On which platform can't you have any newer than C++ compilation target? Which one was it? I think it might have been... Was it the PS3? I think it might have been PlayStation 3 that held me back. I think. It's quite a while ago. S2B is a must-have, not even arguable. Yeah, I just like to move that off into my importer, right? I don't want my core runtime to actually include that. Share the message of love. Awesome engine. Love, love, love. Going to shower to touch some water. Yeah, fair enough. Let's see. Okay. All right. I guess we need to go to this first. So this is a bit of a conundrum, actually. So when we actually... Wait a minute, let me see. Before I say this and confuse everybody. Okay, yeah, there's a couple things here. Okay, so when we request direct from disk, we do have a path, right? So we can load a file directly off disk, but when we request a VFS asset, that I believe contains a package name and an asset name. So when we essentially need the opposite of this to perform an asset write. So previously, the sort of struct K asset that we had here, which we're getting rid of this, had the name and the package name, right? So since we're getting rid of that, we don't actually have a way to extract that information. Furthermore, I think this VFS asset write okay, this is pretty self-explanatory. Okay, so package Boy, we need to update this too, because that's not great. But I guess writing is not that big of a deal, because it's not something we do during runtime. All right, so what this really should do this is looking at the asset package name. So what we really want, we should probably not even pass an asset here at all. We should probably have two functions, one to write a text file, one to write a binary file. And then just provide the content to write and the name and the package name to write to. And then that should feed to, well, we should probably also be able to write to a specific file on disk as well, which we actually don't have. Okay, so let's do this. So we're going to replace this with VFS asset write is now going to become VFS asset write binary, right? And so instead of the asset here, and instead of is binary, we are going to have U64 size and a void pointer to data. Maybe we should call this data size, right? And I think this was using, yeah, U64. Okay, so we're going to take the size of the data itself. We're going to do away with that. Oh, we had size in here. We already had these in here. So we're just going to simplify this then to just that. And then we're going to add to this kname, asset name, and kname package name. Oops, if I can spell it correctly. And then we don't have to pull anything from that asset structure, right? We could just say if package name equals, and we're going to say instead of 0, we're going to say invalid kname. Be a little bit more explicit, right? We didn't have that when we wrote this stuff. And then we'll have asset name there, right? We should probably also write out the name of the function that's doing this, right? Okay. So this is just going to basically do this, and then we're going to delete this, add function here, use package name there. Let's make this consistent. All right, so essentially what we're going to do is I'm going to take a copy of this and we are going to write text, right? And we'll come back to that in a second. So this is binary check is no longer needed. That is the case that we are going to support in this one. And this is just going to be asset name. Okay. And then this one down here is essentially going to be the same thing, except instead of size, this is going to be a constant character array of text, right? And so this is going to do the same thing, only we're going to take the other case down here. And then we want, wait a minute, text write takes size and text. Okay, so we could probably just do, okay, so package, yeah, package asset name. Size is just going to be string length text plus 1, right? And then text. Okay, that makes sense. So we've got those two. I want to say, doesn't this... Does this automatically include... Does this automatically include the null terminator? I don't remember. I don't think it does. So we'll go ahead and include that. Okay. All right, let me see. Let me catch up on chats. Brutarius TV, how's it going? New here? What are you working on? Well, welcome, first off. So, we are building a game engine from scratch using C and Vulkan as our initial rendering backend. So I'll drop a link here in chat so that you can actually access that. Actually, it looks like my chat bot already did it. But that'll take you to this website. And so we are building a game engine completely from scratch on stream. There's a little bit more information here to do a deep dive into it. The meat and potatoes of it is basically it's free and open source. It's designed to be an educational resource. So it's a way to build a game engine. It's not the only way to build a game engine. Not even necessarily always the right way to build a game engine. Sometimes we do things the wrong way, either through exploration or on purpose, just to illustrate why it's the wrong way. But I digress. It is open source and free. So the logic or all the code for it is available on GitHub. It's Apache 2.0 licensed, which means that you can use it either for personal or commercial purposes. Does not matter. All that I ask is that if you use it, you say you used it. There will never be any sort of royalties or licensing fees or any of that kind of stuff. I also don't paywall anything having to do with this channel, right? So I believe that educational stuff should be free. The motivation behind doing this is to hopefully inspire people to want to make game engines and jump into the industry and make some competition for the big boys out there because competition drives ingenuity, and I think that's always a good thing. So this engine itself is cross-platform, so it runs on Windows, Linux, and Mac OS desktop environments with others planned in the future. And so we've got a Discord server with about 1,000 people on it. And then, there's the GitHub link, YouTube, and Twitch. We do simulcast to both of these. And I don't have any sponsors or anything aside from you guys, so there's a Patreon link there if you're interested in that. But yeah, like I said, I don't paywall anything. That's all completely optional. As far as the engine goes, that's always going to be free and open source. So what we're doing now is we're working on the engine, and we're kind of going back and forth between engine development and game dev. And so we're actually in the middle of also writing our first game for this game engine. We've been working on this game engine for a number of years. And now we're at the point where we're actually starting to exercise it a bit by writing a game. And we've identified some pain points and some things that aren't quite probably the way that they should be to streamline that development process. So we're kind of fixing some of those things. And we're going to continue to do that as we develop the game. So we're kind of reworking the way that our assets work now and our import processes to streamline those things a little bit and also delete a bunch of code, which we deleted more code than we added actually in the last stream, which was kind of awesome. So, making things leaner is always better, right? But yeah, that's sort of the quick and dirty explanation there as to what we're doing. So I hope that helps. All right. Thank you for the follow. I appreciate that. Welcome. Let's see. Looks like you guys are just having a conversation over there on the YouTube side. I can't possibly keep up with that many messages. But it's good to see you guys are having a chat over there. All right. So we have these new two functions here, write binary and write text. Yes, they are mostly identical. I suppose we could split some of this logic out. I'm not really all that worried about it. Let's see. The other thing that I did want to do though is we do have file system read entire text file. I do want to see, did we have, let's see, file system write. I don't know if we actually have something to write an entire file and then close it without having to open a file handle. I don't think we do. So I'm probably going to hold off on that last interface point. I don't think we need it right now. So I'm going to hold off on that. So I'm going to take this guy and this guy, and we're going to go to VFS, which is, in case you're wondering what VFS stands for, it's Virtual File System. So we have a virtual file system in here of sorts, and we're constantly working on improving that. Yeah. A virtual file system is basically, you could think of it as a abstraction layer from the operating system's file system, right? So that we don't have to worry about, what operating system we're running on. We can simply just say, hey, I actually want to load an asset that's called this from a package that's called this. And then the virtual file system just figures that out, right? We've got a system of packages underneath all of this where packages hold certain sets of assets that can come with plugins and other things like that. And so that is kind of where we leverage all of that to give us a nice, simple, easy to use interface like this, right? So we have attempts to write the provided data to the VFS or package for the given asset. So we can actually say, we can delete that, and we'll say the provided binary data, we can spell, and then we'll just update our comments here. So we have state, and then we have, let's see, we're going to need asset name, and this is going to be, the name of the asset to be written within the given package. Right, and then this is binary. We don't have that anymore either. That's package name. So package name, the name of the package to write the data into. Good enough. And then we have the size and the data to be written, right? So that's a much more flexible API than what we had before. So I'm actually just going to take this and copy pasta that here. The only difference is going to be text, right? So now we can go back to, let's see, we can go back to our importer. And we can actually, update this this VFS asset write stuff. So there are a couple things that we're going to need to do here. We do need to serialize the image data, which I happen to know was just renamed to be kasset image serialize, right? So we get this serialized block of data. I think the parameters didn't change at all, so we're good with that. And then, obviously we check to see if that's failed. And then we'll come down here, and this is going to be write binary now. And instead of out asset, it's going to be, and I think we do, don't we take, so that was the other half of the issue, because we don't actually have the target asset name, right? So we actually need to extend this a little bit. And before we do out asset, we need to actually provide a name and a package name to write this to. Let's see, maybe we should probably do that before we do all this other stuff, right? So we'll do kname, asset name, and kname package name, right? And obviously that doesn't match our header file, so we'll have to go back and fix that. But I think we'll just need asset name here, package name there, serialized block size, and serialized block. That should be what we need there. Okay, so that is all set. Let's go back to our interface here. Let's see. Actually, it was. Wait a minute. Data size, data. I wonder if I should do asset name and package name first. We should probably also do output asset name, because it's not quite the same as saying out asset name. Yeah, I think that makes more sense. I'm just thinking about parameter order here. I feel like probably we should do these first, right? Because those are going to be things that we're always going to be requiring. So let's just put that first. So we'll do name, package name, then data size, then data, then options for it after that, and then finally a pointer to the asset to write into for memory, right? There we go. Okay. So that makes sense. We probably, let's see, import from path. I guess we don't really need to worry about that as much. That's going to be more of a, well, we do need output asset name and output package name. We do need that. Right? Okay. So this one should be relatively trivial to figure out, I think. Let's see. Hey, I want to show off my C library to you, but I just can't get the link to you. I tried YouTube, Discord, what else is there? Okay, so what I would say is, Bright Programmer, if you go onto the Discord, there is a channel that allows links, which is was it projects, I think? Project progress. There's a project progress in there that does allow links. So if you drop the link there, then yeah. Let's see. Yeah, so I guess yeah, let me know, and I can look at it offline. I'll take a look at that. Yeah, I'll take a look at that offline, but I do see it. So yeah, I'll take a look at it and I'll respond to you probably on Discord, just because I can't really do it on stream, you know. Okay, so import from path. So import from path is basically going to call this function, right? And we just have to essentially read data, or get data and data size, right? And then pass through everything else. So I'm thinking VFS read, let's see, I guess request direct from disk. We probably want to use the synchronous version of that. So engine, actually, you know what? Let's do this. let's take this and put it here. And then the path that we're going to do is just we're going to pass through path, right? We have VFS here. Is binary. So this is going to be binary. So we can hard code that to true. Context size. So we don't have any sort of context, right? So we can actually just do 0 here, 0 here, and then VFS out data is going to be VFS data. It's VFS asset data, data. Right, we'll do that, and then we'll take the address of data. Right, and then what we can do is we can do k assets. Where is it? We can do this k asset image import. You know what? Yeah. Let's do return k asset image import, right? And so we can do output asset name, package name. Data size is going to be data size. And then we're going to do data.bytes. Flip y is just going to be passed through. Same with output format. Same with out asset. And there we go. That is that interface. All right, let's see. Thank you for the follows. I appreciate that. Oh, there's some redeems in here. Thank you for the stretch, redeem, and posture check. My posture is probably rubbish. Appreciate that. Bazooka, first time chat. How's it going? Aaron Depp, why do you prefer C to CPP? So language simplicity for one thing, compilation speed. I don't use most C++ features. I don't really do a lot of OOP, which is one of C++'s main things. I don't use 99% of what C++ has to offer. So I did used to write a lot of what I called C++ Lite, which was C-like C++. But ultimately discovered that I'm like, why don't I just write C instead? And I switched to that, and I like it a lot better. It's much simpler, and I just prefer it. So it's mostly preference, but yeah, I do have some technical reasons behind it as well. Because you like to know what your code is doing. Yeah, exactly. Yep. Precisely. C compiles faster than C++. That's the only sufficient reason to work with it. It compiles much faster than C++. And like I said, I didn't use a lot of C++ paradigms anyways, so I really had no reason to use it. If I was doing lots of OOP and inheritance and all that stuff, sure, but it runs faster also. C-libs should be used for support libs, yeah. In general, it does. I was watching a Factorio devs debugging video, and they have OOP everywhere. And the man used light mode Visual Studio. Ugh. Also, hi Diomon, but dang. Yep. Everyone likes a little bit of pimple. Yeah. Yeah, I prefer to try and avoid that stuff. And actually there's some stuff within this engine that I'm actually even, that was leaning a little bit too much in that direction that I'm actually trying to back out. Like OOP has its place like for certain things, right? But like for systems level code, not really. I use light mode only when I need light, screen light on my face, like when I'm in a meeting. Oof. Is that why your name is Bright Programmer? Because you use light mode? That would be pretty funny, actually. No, I'm just kidding. Let's see. Does this... Check out data context to see if it needs freeing, as this is... Okay, so we don't use the context. Let's see. So I don't think we actually need to release this. I think we can actually just use... We can use the data directly, right? Although... This does not free any of that stuff, so actually we do need to release that. I wonder, did we actually make a... We should probably make a VFS asset. I guess it would be VFS asset data cleanup, right? Although really the only thing it needs to clean up is potentially this. Well, no, it could have to do that too. Okay, yeah, we should probably actually do that. I don't know why I didn't actually put something in there to do that. Yeah, let's get that in there. So we're gonna do another function called KPI. We're going to export that symbol. We're going to say VFS asset data cleanup. I don't think we actually need the VFS state for that. I think we can literally just say VFS asset data. And then also I'm going to say a B8 release context, right? So if that is true, then it tries to release the context based off the size that was provided. But that should have the caveat of, it's not going to know to clean up any dynamic allocations that the context itself had. So we should probably notate that. So brief releases, or I guess, yeah, releases resources held by data. And then param data, a pointer to the VFS data to be released. And then release context indicates if the context should be freed here. Note, this does not account for any dynamic allocations made within said context. And we actually can just do return type void, actually. We don't need any sort of returns for that. So let's take this over to, let's take this over here. Right, and so if we have data, then we'll go ahead and do the thing. So if we have data, and we have data size and data bytes. Also, let's see, do we have something in here which indicates binary or not? No, I guess we don't. Okay. That might be an issue, but we'll come back to it if we hit it. So all we need to do here is we basically just need to do a K free. The block is going to be data bytes. The size is going to be data size. And the memory tag, ooh, that could be anything. Well, I think actually maybe not. So let me see. Maybe it's... I don't want to just assume, though, because if I get this wrong... Oh, I really need to refactor that to get rid of the requirement of a memory tag there. We shouldn't require that on a free. What's the tag and allocation? You mean like what's its purpose? So right now, technically, it's just for reporting purposes. But what I intend to use this for is eventually we're going to split up our custom allocator to perform different types of allocations based off of the tag. And it's going to basically put those different allocation or those different tag types in different pools of memory to try and keep like allocations contiguous, or at least closer. Oh, you mean what was the tag used during allocation? Yeah, that's what I was trying to think of. I have a feeling it was probably that, but do I have it in here anywhere? It's probably going to be a BNK package if I had to guess, but... Well, here's the source path and path. Those are the only 5 instances of it. So, might be in K package, I'm thinking. Let's see, out package, internal data. Okay, that's not what I want. There it is. Yeah, it is memory tag asset. Okay. So this is one of the reasons, like, one of the things I've been wanting to actually refactor for a while is the fact that you have to, when you're freeing, you have to provide the tag. Which should already be known by the allocator, right? So that's, not great to have to do that. Actually, you know what? I'm not going to do that. Let's do... You know what? I'm going to actually split this out. I have a reason for this. All right. So if release context and data context size and data context, then I essentially need to do the same thing. Although the same issue comes into play here. Because we don't actually know what the original memory tag was. So I think it would be, what I really need to do is change this API to just require this. And maybe not even the size, I think. Just the pointer, right? Because we do have No, we aren't currently tracking that. I think that's why I haven't done it. I don't think we're actually keeping an internal lookup table of that. I think that's the reason why. Nice glasses, nerd. I can say that I have glasses too. Nice. How's it going, Orblish? Yeah, I have proper Coke bottles though. I mean, these are the super lightweight lenses, and they're 2Cs thick at least, maybe approaching 3Cs. Coke bottles, exactly. Yep. All right. So if we have, okay, I'm gonna put. The problem is this context. You know what? This is impossible for me to actually know. So I'm going to back that bit out and just put a note. I'm going to put a note on here. Right there. So we're just not even going to handle that at all. If it has context, that should be released before this. I suppose we could warn about it, right? So if data context, right? If that's set, or data context size, then we can do possible memory leak, context size found on VFS asset data, right? And then we just do function, right? We'll just bleat about it. But finally, we need to do K0 memory. The block is going to be data, and the size is going to be size of VFS asset data. So now we can actually clean this up. So we should do B8 result is that, right? And then we'll do VFS asset data cleanup, and we'll take the address of data, right? And then return result. The other thing that this doesn't keep in mind is what I believe we have data result. Yeah, we need to check that too. So data result equals VFS result success, right? So B8 success equals that, right? So before we even actually try to do like any of this importing, right, we need to make sure that we actually read the file correctly. So if not success, then I guess we can do this. Failed to import image from path. See logs for details. And then return false there. Okay. That should be everything that we need to handle that, right? So now we can actually do an image import either from a path directly, directly to a package, or if we've already read it from disk, we can actually load it in this way. So I think this is the way that we're going to handle all asset imports for all the other types of assets at this point. Sort of as a non-standard standard, right? And I'm going to say non-standard standard because the format of these might change, right? In terms of what properties and parameters they require, but the overall flow will be the same between them. So we'll have, output asset name, output package name, and then path for importing from path, and then for just standard imports from memory, we'll have this one. So it'll just be name, asset name, package name, then data size, data, and then parameters, and then out asset. I think that makes the most sense. So our new pipeline will essentially reference this in one of two ways. So we have, let's see if I can spell manifest correctly. We have this asset manifest, right, which is essentially where we get all of our asset paths from. And some of these have source paths, right? So any of these that have a source path is going to use a importer. So the way that I'm envisioning the new pipeline working is we'll have one version of it that reads this file and says anything that's got a source path, let's go ahead and check first to see if this file exists in the path, right? And if it doesn't, then we'll go ahead and import this, and we'll use the extension to figure out what importer we need to use. If it does, then we need to check the timestamp of this and make sure that the timestamp of the imported asset is newer than the source asset. And as long as that's true, then well, let me think. If the source asset has a newer timestamp than the actual primary asset, then it means it needs a new fresh import. And so whenever you run it, it won't just automatically import everything. It'll run that check first and only import what we actually need to import, which will obviously make things faster down the road, after you've done imports of most of your assets. The other thing that this will facilitate is we can then just run something against this file even while the engine is running. And we can tie our hot reload to this file instead of the source file. And then whenever the new file is written, then at that point we can kick off the hot reload process from the actual engine native format. And that takes all of the complexity of having to say, well, was this imported from a source file? What was that source file? Go grab that and reload it and try and do it that way. I think that's going to make things a lot simpler code-wise. And if we essentially set the thing that reads this file up to also watch all of the source paths for updates, we could theoretically have a program that runs that, just automatically watches this file, and whenever it updates, it says, hey, am I newer than this? If so, do an automatic import, write the file to disk, and then the engine, if it's running, will pick that up and say, here's the hot reloaded asset. And the advantage of this will be if we set it up that way, right? We could essentially create what amounts to almost like a service that runs. If this service is sitting there running, then even when we open up a like an editor down the road, we can actually have that editor directly talk to the service and trigger these things manually. So even kind of going into the future, if we design this right, we should just be able to plug it right into our editor and have that work. Um, so yeah, I think that makes sense. Oh yay, someone else in asset import hell. Yeah, I mean, yes and no, because we had a system that works, right? But I found it a little bit too cumbersome. So I'm actually working to simplify it at the moment. But yeah, first time chatter, by the way, welcome. Had a thought last week. Would it make sense to have Hot Reload only watch the engine format binary and have a separate executable you can launch as a child process to watch the source path and re-import asset? That's actually exactly what I was just talking about, pretty much. I don't know if you sent that before or after I started talking, but DM on that's pretty much exactly what I'm going to do. Yep. Currently in the nightmare that is importing skin meshes and animation data from GLTF. Yeah, we are eventually going to be hitting that up for sure. Thank you for the follow, by the way. Okay, good to know I'm not crazy. Yeah, that's pretty much exactly what I was thinking. And if I set that program slash service, whatever we're going to call it, if I set that up right, we should be able to have it should be able to communicate with our editor. So we can actually, launch the editor and just automatically start that up as well. So I think hot reloading in the engine is actually going to be a lot simpler if we go this direction. Let's see. There's a lot of YouTube comments. I can't keep up with them on this side. It's pretty active tonight. Let's see. Stop doing game engine series and make a new one called Vim Motions from scratch. Yeah, I know, right? He loses base doing that. Of no interest in Vim console programming. Can't think of anything I abhor more. That's fair enough, Adam. Yeah. I mean, everybody has that. That's the reason I structured this project to work either with this or the editor that shall not be named. This one. Yeah, I mean, the idea is that I didn't want to necessarily force you into using one particular editor. Full blown Visual Studio comes to mind. Just preference, many prefer it. Yeah, exactly. That's the thing, right? But I don't want to enforce anything. I can't tell you though how many people have been like, you should just use CMake, and I'm like, no, because that's forcing a dependency. I don't want to do that. All right. So, you for one love an MSVC project. See, I used to until I discovered not having one of those things and not having to deal with Microsoft's tool sets. And the non-standard way of configuring things. And now I much prefer working this way. CMake can generate one, yes. But I don't want to have that be a dependency. Like, nothing is more annoying to me than when I go to look at a project and I just want to run it, and it's like, oh, crank up CMake and run this. Like, but I don't want to do that. MSVC used to be buggy as hell. Yeah, it still is. It's gotten so much worse. It's so slow these days, too. Like, and I'm talking, I've been using Visual Studio since version 6. And it's just so heavy and so slow now. It's insanity. First time chatter smells serious. I love the name. How's it going? Welcome. Rugs 88 or 888 rather. How's it going? I hope you're doing well. Currently in the nightmare that is import. Oh wait, I already read that one. Okay. Okay. You mean MSVC or Visual Studio? Well, okay, when I say MSVC, I mean Visual Studio in general. with their projects and all that stuff. Like Visual Studio, the IDE is just huge and bloated and slow. MSVC is obviously just a part of that, but okay. I'm trying to decide whether I want to move on to the next importer or end for tonight and potentially pick it up for tomorrow. Because I don't have that much time left anyways, and I have to get up early for work in the morning. So I'm thinking this is probably where I'm going to end it. But at least we have like an idea of how we want all these importers to work. Probably what we should do. Yeah, see the other importers are going to be broken. So I'm going to have to go through those. Probably what we should do is in the next stream, if I haven't gotten a chance to actually handle some of these importers offline. We'll have to fix those, and then maybe we'll write the process that reads this in and performs the imports. And we'll probably just start it super simple and just import every single time, and then, make it fancy from there and build on top of it, get it working, and then, move from there. Although, frankly, for now, I just need the import bit to just compile so that I can actually run the engine again and get everything built. But I digress. Thank you for the follow. Appreciate that. Student studying CS. Awesome. Welcome. I hope you get something from the series. All right. I use it really because I'm used to the interface, and the IntelliSense is a requirement for me. So, even with this, I have IntelliSense, right? So there's, that's not something that's specific to Visual Studio anymore. There's so many other editors out there that have it that are faster and more, even this pile of crap is better than, it's quicker and more lightweight than full-blown Visual Studio. Yeah, now you do. Yeah, I've broken it once or twice, but yeah. All right. LSPs are a thing now. Yeah, exactly. And that's what I'm using here as an LSP. And I think when Notepad comes out, that's going to have limited LSP support, at least for C. I'll probably use Clang D for that when I get that done. But Notepad is quite a ways off. Well, let's see. Not sure how OG you are, but I started this 15 years ago. Let's see. Wait. See me. OG in terms of what? Oh, back then IntelliSense was brand new and proprietary. It still is. Still unmatched. Yeah, I'm trying to think. Like I said, I've been using I used Visual Studio all the way back to version 6, and I can't remember if it had it that far back or not. That was the first version of Visual Studio that I used. That was Visual Studio 6 back in the day. I can't remember off the top of my head if that had IntelliSense or not. I don't remember. But yeah, when it first came out, it was a new huge thing, but now everybody has it. Would have been experimental then. Yeah, that rings a bell. I think you had to I think there was an update for 6 that you also then had to enable, I think. I can't remember. It was so long ago. It was a beta feature. Maybe that's what it was. Beta build. Yeah, maybe that's what it was. It's been a while. Visual Studio 6 was how long ago? Yeah. But yeah, when I started using Visual Studio 6 was when I started writing C++ code. So that was a long time ago. Before that, I was using... before that, I basically made a jump from... I made a jump from web, and before that, QBasic. So QBasic has none of this stuff. So Yeah. You basically used MS-DOS edit to write those files. So I don't know. That's pretty OG, I think. But anyway, I digress. Might still be better than Xcode though. Yeah, I try not to use Xcode. Like, I try not to ever open it on purpose. The reason I like this setup so much too is because it is cross-platform. Like my NeoVim config works on all the platforms I support for this engine. So, all right. Let me find somebody to raid. And while I do that, I do want to thank you guys for being here, and all the new follows and all the new folks that are filed in. Welcome. I really appreciate you guys being here. We're going to stream again at the same time tomorrow night, which is usually just before 9 p.m. Eastern. So we will be back tomorrow, but yeah, I really want to thank you guys for being here. If you haven't already, I would also encourage you to follow, because I'm trying to grow the channel and thus trying to reach more people, and every single one of those things helps, and I greatly appreciate it. So whether that's on the YouTube side or the Twitch side, or if you're so inclined, both, I greatly appreciate it either way. For those of you who have followed, thank you very much. I greatly appreciate that. I'm just looking through the list now to see if I can find something that is kind of semi-related to what we're doing here. I've got a couple of things that I can fall back to. If not, just takes me kind of a second to scroll through the list. Doesn't look like there's a lot of C or C++ programming going on right now. So I'll tell you guys what, actually. We're going to raid Odd Oculus. He raided me the other night. And he's using Unreal Engine, but he is using C++. So he is making a pretty, I think it's a pretty cool looking game so far. So let's go over there and check out what he's up to. And yeah, thank you guys so much for being here. I really appreciate you guys. And I will see you guys on the next stream. See ya.